So we can start looking at these limits algebraically, which is a little bit more challenging. So we have to do some, well, first of all, make sure we try to evaluate the limit at the beginning. So we don't want to do any algebraic manipulations or anything like that if we can actually plug in and evaluate the limit. Okay, so if we can't, then we need to do some algebraic manipulation to see if we can resolve that limit. So here, when x equals -5, when I plug it in, I'm going to get 0 on top and 25 minus 25, so 0 on the bottom here. So I'm going to end up with 0 over 0, and that's a problem. Okay, so I can't really resolve it that way, so I'm going to have to see if I can somehow simplify this algebraically. So for this one here, we can just write it like this. The limit as x approaches -5, we have our x plus 5 factor in the numerator, and we can actually generate an x plus 5 factor in the denominator as well. They cancel out, so we can work out the limit now. The limit works out to be -1 over 5. Okay, and what this means is that there is a hole in this rational. You have to graph it. There's a hole in this graph at -5, y equals -1 over 5. So this one here again, we can just plug in and we see we get 0 over square root 9 is 3 minus 3 is 0. So again, we have a bit of a problem here. So we have to think, how can we rearrange this algebraically? Well, this one here is kind of hard to see, but this is actually, if we compare it to root x and 3, this is squared of root x and squared of 3. This is actually a difference of squares. We can actually express this numerator as root x minus 3 root x plus 3. Okay, and then we end up with root x minus 3 on the bottom. Okay, and so we can do the limit of this because we can actually get rid of that divide by 0. So now I have the limit as x approaches 9. Okay, I can cancel those out. Well, now I can resolve this limit. I end up with square root 9 plus 3. That works out to be, the limit is 6. So here's another one here where we end up with 1/2 minus 1/2 is 0. 2 minus 2 is 0. Okay, so, well, what can we do here? Well, we have to do some algebraic rearrangements. And part of it is, this is hard to see this ratio. So we should really simplify this ratio, this complex fraction. And we should really express it like this. 2 minus x over 2x. And this is all over x minus 2. Okay, and we can do the limit. Right, it's the limit. And we can actually algebraically simplify this complex fraction. The limit as x goes to 2. So this numerator and this denominator actually really are the same factor. They just differ by a negative. So I'm going to write it this way. The limit as x approaches 2, I'm going to have negative x minus 2. And really there's only a numerator and denominator in this fraction. That's in the numerator, that's in the denominator, that's also in the denominator. So I'm going to write it as 2x bracket x minus 2. Those cancel out. I can now plug into my limit. I get -1 over 2 times 2, so -1 over 4 works out to be my limit. And again, if we're not sure about these, if we get stuck, we can always graph them. And graphing them, and even if you get them right, it's good to graph them because it gives you a good sense of what you're doing. Okay, so this one here, we're going to end up with 9 times 0 over 0. And this one here, we're going to, because of this absolute value nature, we kind of have to do this in 2 parts. Okay, so I'm going to do this as a limit, because really, remember that as we go to 0, from one side of the absolute value, something different is happening compared to the other side of 0. So as we approach 9 from the positive side, that's going to give me my positive square or positive absolute value. So I can just do this, x bracket x minus 9 over x minus 9. Okay, well these can cancel out, and I'm going to end up with a limit of 9. Okay, well that's great. So if I do this from the other side, okay, so the limit as x approaches 9 from the negative side, okay, because on the other side of 9, we're going to have a negative inside the absolute value. So we're going to have to actually change that. So that's behaving differently than on the right-hand side or the positive side. So we're going to have this x negative x minus 9. Okay, because we got to flip it around because this is actually a negative. We got to make it a positive with that extra negative here. And then we're going to have x minus 9. Okay, well those cancel out. I have a negative 1. This x becomes 9, and we end up with negative 9 from the left-hand side. So from the right-hand side and left-hand side, these are different. So we have to say that the limit does not exist. Okay? Well, that means then that, well, we've actually worked this out. Okay, so this is actually the first one up here. Okay, so the limit, we can just say, well, this is the limit as x goes to 9 from the positive side. Really is just the limit of the positive version of that absolute value. So we just take away the absolute value, and we end up with our limit equaling 9 like we had before. So this is a very interesting one because we have to be considerate of the fact that as we approach 9, this is going to affect the absolute value. From one side of 9, the absolute value behaves differently than on the other side of 9. And this is why we made those piecewise functions, because they behave differently on one side versus the other. So let's try this one here. This is, well, we're going to get 0 over 0 again. So we can actually express the numerator this way: square root x minus 9 times square root x minus 9. Okay, because x minus 9 is equal to square root of x minus 9 times x square root of x. Well, we can cancel out one of those square roots on top and bottom, and then work out just plug in our 9. Okay, because we don't have a divide by 0. So there it is, our limit is equal to 0. This one here, 1 over sine x. Well, this goes to 0. Well, what's happening to the 1 over x as we go to 0? So we have to be a little bit wary here, because 1 over x as it approaches 0 is going up to infinity. Okay, so this is y equals 1 over x. So as they approach 0, it's going up to positive infinity. So basically we're saying the sign of infinity. Okay, so what is the sign of infinity? Okay, well, we can't really do that. In fact, what's going to happen is the sign value is just going to go bounce back and forth, back and forth, back and forth, back and forth. So as we approach 0, that's going to end up looking like this. Okay? Here's our sine graph. It's going to be going up and down, up and down, up and down, and then it just starts going up and down, up and down, up and down, up and down. Okay, and so what ends up happening is it doesn't actually focus in on one value. So we have to say that the limit does not exist. Okay, so in this case, the limit does not exist. And the reason is because it's just bouncing back and forth between positive 1, negative 1. It's not ever going to focus in on one or the other, or even in the middle. Okay, because it's just going to keep going and going and going and going. And sine, the way sine works, it just goes up to 1, down to negative 1, up to 1, down to negative, and it's just going to keep repeating that cycle. There's no end to that cycle. So it never focuses on one value. Okay, for this one here, this one is, we have to think, what's happening to that 1 over x again as we go to 0 from the positive side? Well, we take a look here. It's going up to positive infinity. So then we have to ask ourselves, what's happening to the arctan as we go to positive infinity? Well, this is the arctan graph here. So we really should want to have a sense of what the arctan looks like. So as the arctan goes to infinity, what's happening to the y-coordinate? It's getting closer and closer to the angle pi over 2. So in this case here, we just have to use kind of a sense of understanding of this to be able to work this out. If we understand what this graph looks like, arctan, then we can work out the limit of the inside piece and then work out the entire limit. So in this case, this is going to just end up being 1 plus pi over 2. Okay, because as we go out to infinity, this arctan value is going out to up, just trying to get to pi over 2. So that's our limit.